Hello there, and welcome to the Sleep Science Calm Stories. Maybe you're the kind of person who likes falling asleep to distant things. The quiet turning of planets, the slow drift of galaxies, the ancient lights that arrive from across space long after their journeys began. The night sky has always been a place for that kind of gentle curiosity. A dark canvas scattered with points of light that feel steady, calm, and almost eternal. For most of human history, those stars appeared completely unchanging. They rose each night, crossed the sky in familiar patterns, and faded again with the morning. And even now, when you look up at the stars, they still seem almost perfectly still. But behind that quiet appearance, every star is slowly changing. Not quickly, not dramatically, but steadily, patiently, across spans of time so long that entire civilizations would rise and disappear before a single small stage of a star's life had finished unfolding. Tonight, we'll spend some quiet time with one of those stages, the chapter of a star's life when it grows older, softer in color, and far larger than it once was. A stage astronomers call the red giant phase. It may sound dramatic at first, a giant star glowing deep red in the darkness of space. But in truth, it is one of the most natural and common transformations in the universe. Most stars, given enough time, will pass through this quiet chapter, even our own sun. But that future is so distant that it belongs almost to another age of the universe entirely. For now, we can simply explore the idea together. A star that has spent billions of years shining in quiet balance, slowly beginning to change. Before we drift further into the story, if you enjoy calm journeys through science and the quiet mysteries of the universe, you're always welcome to subscribe and return whenever you'd like more gentle explorations like this. And if your attention drifts at any point tonight, that's perfectly fine. There's nothing you need to hold on to. The story will keep moving gently forward whether you catch every word or not. You can simply listen loosely, letting the ideas pass by like distant lights. And somewhere out there, far beyond the quiet room around you, the stars themselves are continuing their slow stories, because what we see when we look up at the night sky is not a collection of permanent lights. It is a vast population of living systems. Each star is a sphere of gas held together by gravity, shining because deep inside it, nuclear reactions release enormous amounts of energy. At the heart of most stars, including our sun, hydrogen atoms are constantly fusing together. This process is called nuclear fusion. Under the immense pressure and temperature inside the core of a star, hydrogen nuclei collide and combine to form helium. Each tiny reaction releases energy, and the combined effect of countless reactions every second is what allows a star to shine. The energy produced in the core slowly works its way outward through the star, eventually escaping as light and heat, and that outward flow of energy balances the inward pull of gravity. Gravity is always trying to compress the star. Fusion is always pushing outward. For billions of years, these two forces remain in delicate balance. From the outside, the star appears calm and steady, but that balance depends on something very simple: fuel. The hydrogen at the center of the star is slowly being used up, not quickly. A star like our sun has enough hydrogen to shine steadily for around 10 billion years. But even 10 billion years is not forever. Over immense stretches of time, the supply of hydrogen in the core gradually decreases. And when that central fuel begins to run low, the balance inside the star begins to shift. This is the quiet beginning of stellar aging, the moment when a star that has spent billions of years in stability begins to move into its next chapter. Astronomers sometimes call the earlier stage of a star's life the main sequence. It's the long, stable middle of a star's life, but eventually, the main sequence ends, not with a sudden explosion, not with a violent collapse. Instead, the star begins a slow internal rearrangement. As hydrogen in the core is consumed, the core itself changes. The fusion reactions that once took place right at the center begin to slow down. Gravity, which has been patiently waiting the entire time, begins to press inward a little more strongly, and the core of the star slowly contracts. But something surprising happens next. Instead of shrinking overall, the star begins to grow larger. As the core contracts and heats up, the surrounding layers of hydrogen begin to fuse in a shell around the core. This shell of fusion produces enormous energy, and that extra energy pushes the outer layers of the star outward. The star swells. Its outer atmosphere expands farther and farther into space, and gradually, the star begins to change in appearance. The surface cools slightly as the star expands. Its color shifts. A star that once glowed yellow or white may begin to glow orange, and then deeper red. And this is the stage astronomers call a red giant. But before we explore that transformation in detail, it helps to pause for a moment and consider something quietly astonishing. The stars above us tonight may look like tiny points of light, but many of them are not the same kinds of stars they were millions or billions of years ago. Some have already passed through dramatic transformations. Some are still quietly burning hydrogen in their cores, and some, even now, are expanding, growing larger and softer in color as they enter the later chapters of their long lives. Stars are not permanent lights fixed in the sky. They are evolving systems, slowly unfolding stories written across unimaginable spans of time. It's easy to miss how strange that really is. From our perspective here on Earth, the sky feels stable, but in reality, every star is quietly moving through a life cycle: formation, youth, stability, aging, and eventually, transformation. The changes are simply so slow that we rarely notice them. Even over the entire course of human history, most stars appear almost exactly the same. Yet, if we could watch the sky across millions of years, or billions, we would see the stars shifting, changing color, expanding, fading, and sometimes growing into something far larger than they once were. And among those transformations, the red giant stage is one of the most beautiful, a time when a star that once resembled our sun becomes something immense, its outer atmosphere stretching outward across vast distances, its color warming into deep shades of orange and red, a glowing lantern in the darkness of space. And there is something quietly comforting about the way this transformation happens. It is not sudden. It is not violent. Instead, it unfolds slowly, a patient process driven by gravity, heat, and time. Even now, across the galaxy, countless stars are entering this stage. ancient suns expanding gently into enormous glowing spheres, and their light, traveling across the depths of space, continues its long journey toward distant worlds. Some of that light is already reaching Earth tonight, and if your attention drifts as we continue exploring these quiet stellar stories, that's completely okay. You don't need to remember every detail. You can simply listen and let the ideas move past like distant stars themselves, because the universe has been carrying out these slow transformations for billions of years, and it will continue doing so long after this night has passed. And there's something quietly comforting about that. The stars are not fixed. They are alive with slow change. And one of the most remarkable chapters in their long stories is just beginning. Some stars begin their lives in quiet clouds of gas, drifting through space for millions of years before gravity slowly gathers them together. But once a star has formed and settled into that long middle phase of life, the stage astronomers call the main sequence, it can remain stable for an astonishing amount of time. A star, like our Sun, will spend roughly 10 billion years in this steady condition. For most of that time, very little seems to change. Deep inside the star, hydrogen atoms are constantly fusing into helium. The reactions happen at temperatures of millions of degrees, under pressures far beyond anything we experience on Earth. Yet the balance created by those reactions keeps the star remarkably steady. Gravity presses inward, fusion pushes outward, and for billions of years, those two forces remain almost perfectly matched. From the outside, the star appears calm, a constant light in the darkness, but the quiet stability of a star hides an important truth. Inside the core, hydrogen is slowly being consumed. Each second, in our Sun alone, around 600 million tons of hydrogen are converted into helium. That may sound like an enormous amount, and it is, but the Sun contains so much hydrogen that this process can continue for billions of years before the fuel begins to run low. Still, over time, the core gradually changes. Helium slowly accumulates at the center. Unlike hydrogen, helium does not fuse easily under the Sun's current conditions. So, as the helium builds up, the active region where hydrogen fusion occurs becomes smaller and smaller. The star is still shining, but the structure inside it is quietly evolving. And eventually, after billions of years of steady fusion, the central hydrogen supply becomes too depleted to maintain the same reactions in the core. This moment does not arrive suddenly. It unfolds slowly, but once the hydrogen in the core can no longer sustain fusion, the delicate balance inside the star begins to shift. Without fusion pushing outward in the center, gravity takes a slightly stronger hold. The core begins to contract. Now, contraction might sound like the beginning of a star shrinking, but the physics of stars often leads to surprising outcomes. As the core compresses, it becomes hotter. The temperature rises, and the increased heat begins to ignite hydrogen in a thin shell surrounding the core, just outside the region where the original fuel was used up. This new layer of fusion begins burning hydrogen even more intensely than before. The energy produced in this shell pours outward through the star, and that surge of energy begins to push the outer layers of the star farther and farther into space. Instead of collapsing inward, the star begins to swell, slowly at first, then more dramatically. Its outer atmosphere expands outward, growing wider and wider. At the same time, as the star expands, its surface cools slightly. The light it emits shifts toward longer wavelengths. Instead of the yellow-white glow of a younger star, the light begins to soften into deeper shades of orange and red. And this is when astronomers say, the star has entered the red giant stage. It may sound like a dramatic change, but from the inside, the process is gradual and patient. The star is not exploding. It is adjusting, aging in its own quiet way, and the scale of that expansion can be almost impossible to imagine. A star that once had roughly the same size as our sun may expand until its outer layers stretch hundreds of times farther into space. If our sun were to begin that transformation today, its atmosphere could eventually extend beyond the orbit of Mercury, possibly even farther. Planets that once circled safely around the star could find themselves inside the expanded outer layers. Yet even as the star grows enormous, something curious remains true. Most of the star's mass stays concentrated near the center. The outer atmosphere becomes thin and diffuse, more like a glowing cloud than a solid surface. If you could somehow float near the outer layers of a red giant, you would not find a sharp boundary like the surface of a planet. Instead, you would drift through layers of hot gas, gradually becoming thinner the farther you traveled outward. The gravity there would feel surprisingly gentle because the star has spread its outer layers across such enormous distances. The gravitational pull at the surface becomes weaker. Gas can drift more easily. Winds can carry material away, and the star's vast atmosphere becomes a slowly shifting ocean of glowing plasma inside that enormous envelope. However, the real engine of the star is still operating. The hydrogen-burning shell surrounding the core continues releasing tremendous energy. This shell of fusion is one of the key features of red giant stars. It is like a thin furnace wrapped around the contracting core. The heat produced there pushes outward on the surrounding layers, and the star continues to expand. The structure of the star now looks very different from the earlier stages of its life. At the center lies a dense helium core. Surrounding that core is the thin shell where hydrogen fusion is taking place. And around that shell stretches the enormous atmosphere of the red giant, glowing softly in shades of orange and red. But even as the star swells outward, the core itself continues to change. Gravity keeps compressing it. The pressure grows higher. The temperature rises steadily, and deep inside that tiny central region, conditions become more extreme with every passing million years. Temperatures climb toward 100 million degrees. At those incredible temperatures, something remarkable can eventually occur. Helium, which had been accumulating quietly in the core, can finally begin to fuse. This is a much more difficult reaction than hydrogen fusion. Helium nuclei carry stronger electric charges, which means they repel each other more strongly. To push them together requires tremendous heat and pressure. But once the core becomes hot enough, helium atoms can begin combining to form heavier elements. Carbon is one of the most important of these. The process happens through a reaction known as the triple alpha process. In this reaction, 3 helium nuclei combine to form a single carbon nucleus. And in that quiet transformation, deep within an aging star, one of the fundamental elements of life begins to take shape. Carbon is the backbone of organic chemistry. It forms the basis of molecules that eventually make up living systems. Yet the atoms of carbon that exist throughout the universe did not exist at the beginning. They had to be created, and many of them were forged inside the cores of red giant stars. This means that some of the atoms found in living organisms on Earth were once created in stars that lived and died long before our solar system even formed. The connection between stars and life may seem distant at first, but the deeper astronomers study stellar evolution, the clearer that connection becomes. The universe is not only a place of light and gravity, it is also a place where chemistry slowly evolves, where simple atoms combine into more complex ones, where ancient stars quietly manufacture the ingredients that will later become planets, oceans, and living worlds. And all of this begins inside the hidden cores of aging suns. Yet, from far away, the red giant itself still appears calm, just a warm star glowing softly in the darkness of space. If you were looking at such a star from a distant planet, you might see a vast reddish sun hanging in the sky, much larger than the sun we know today. Its light softer, its color deeper, its atmosphere stretching far beyond what younger stars ever reach. And while the star might appear quiet and steady from a distance, its interior would still be alive with slow and powerful processes, shells of fusion, a core growing hotter and denser, atoms being rearranged in ways that will shape the future chemistry of the galaxy, all unfolding slowly, patiently, across spans of time so vast that even entire species could rise and vanish before the star finished this stage of its life. And if your thoughts wander as we move through these long cosmic stories, that's perfectly all right. There's nothing here that requires effort. The details can come and go, like the slow glow of distant stars appearing and fading across the night sky, because the universe itself unfolds at a pace that invites patience. Stars take billions of years to grow old. Their transformations stretch across ages of time, and somewhere out there, even now, countless red giant suns are continuing this quiet chapter of stellar life, expanding gently, glowing warmly, and slowly shaping the chemistry of the galaxy around them. Deep within those enormous stars, the slow work of transformation continues. A red giant may appear calm from the outside, just a warm orange glow in the darkness. But inside, the star has become a place of remarkable pressure and heat. The core, which once quietly fused hydrogen for billions of years, has now grown much smaller and denser. Gravity presses inward constantly. With no hydrogen fusion happening directly in the center anymore, the core contracts further under its own weight, and as it contracts, the temperature rises. This is one of the strange and beautiful patterns of stellar physics. When gravity squeezes matter inward, heat builds up. The compression itself becomes a source of energy. The atoms inside the core are forced closer together, and the collisions between them grow more energetic. Temperatures climb to extraordinary levels. In many red giants, the core eventually reaches temperatures exceeding 100 million degrees. At such extreme heat, the conditions finally become right for helium fusion to begin. But the path to that moment is not always smooth. In some stars, roughly the size of our sun, the helium core becomes so dense that it behaves in an unusual way. The matter inside it enters a state known as degenerate matter. This term doesn't mean something broken or deteriorated. Instead, it refers to a strange property of matter under extreme pressure inside degenerate matter. atoms are packed so tightly together that the behavior of electrons begins to follow the rules of quantum physics more than ordinary thermodynamics. The pressure inside this kind of matter depends less on temperature and more on the quantum properties of the particles themselves. And because of this unusual condition, the core can continue heating up without expanding in the normal way. Eventually, the temperature becomes high enough for helium fusion to ignite. When this happens in a degenerate core, the reaction can begin very suddenly. Astronomers call this moment the helium flash. Despite the dramatic name, the event is not something that would appear as a visible flash to distant observers. It occurs deep inside the star, but the energy released during this ignition is enormous. For a brief period, the core releases more energy than the star normally produces, yet most of that energy goes into rearranging the structure of the core itself. The intense heat allows the core to expand slightly, relieving the extreme pressure that had built up. Once the core expands, the helium fusion settles into a more stable process, and the star enters another chapter of its life. In this phase, helium in the core begins fusing steadily into carbon and oxygen. The star is still enormous. Its outer layers still glow red and extend across vast distances. But inside, the internal engine of the star has changed. Instead of hydrogen burning at the center, helium is now the primary fuel. Meanwhile, hydrogen fusion continues in a shell farther out. The star has effectively developed multiple layers of nuclear reactions: a helium-burning core, a hydrogen-burning shell, and an immense outer atmosphere of glowing gas. The structure may sound complex, but the star continues to shine calmly from the outside. From far away, the red giant remains a quiet presence in the sky, just a large star glowing with warm orange light. This is one of the quiet paradoxes of astronomy. The most extraordinary processes in the universe often hide behind the calmest appearances. If you could somehow approach the outer layers of a red giant, you would find an environment very different from the sun we know today. The surface gravity there is far weaker because the star has expanded so dramatically. Its outer atmosphere is stretched across enormous distances. The pull of gravity becomes gentle compared with younger, smaller stars. Gas in the upper layers moves slowly and freely. The atmosphere itself becomes thick and extended, sometimes forming giant convective cells. These are vast regions where hot gas rises from deeper layers and cooler gas sinks again. On the sun, convection cells exist too, but they are relatively small compared with the size of the star. On a red giant, these convective cells can become enormous. Some may stretch across significant portions of the star's visible surface. Hot gas slowly rises upward, glowing more brightly. Then it cools and sinks back down into deeper layers. The motion is slow, almost like the gradual movement of thick liquid. From a distance, this convection can cause subtle variations in the star's brightness. Red giants often brighten and dim gently over time, not in sudden bursts, but in slow rhythms. Some of these pulsations take months, others may take years. The star expands slightly, then contracts, then expands again. A quiet, breathing motion on a scale so large that entire planets could fit inside the rising and falling layers. One well-known example of this kind of star can be seen with the naked eye from Earth, the star Betelgeuse, in the constellation Orion. If you look at Orion on a clear night, Betelgeuse appears as a reddish point of light marking the hunter's shoulder. Even without a telescope, its warm orange color can sometimes be noticed. Betelgeuse is a red giant, or more precisely, a red supergiant, which is an even more massive version of the same stage of stellar life. It is enormous. If Betelgeuse replaced our Sun, its outer atmosphere would stretch far beyond the orbit of Mars. Yet, despite its immense size, Betelgeuse has a very low density in its outer layers. Much of the star's atmosphere is so diffuse that it resembles a thin, glowing cloud, and like many aging stars, Betelgeuse slowly sheds material into space. The gentle gravity at its surface allows gas to drift outward. Stellar winds carry atoms away from the star. Over time, the star releases enormous quantities of material into the surrounding galaxy. This process is one of the most important ways that stars enrich the cosmos, because the material leaving the star contains elements created inside the stellar interior. Carbon, oxygen, and other atoms that were not present in the early universe. These elements are carried outward on slow streams of gas. Some drift for millions of years through the interstellar medium. Others eventually become part of new clouds of gas and dust. And within those clouds, gravity may one day begin gathering material into new stars. The cycle continues, old stars expanding, shedding their outer layers, new stars forming from the remnants, the universe slowly recycling its own material across generations of suns. It may seem almost impossible to imagine these vast timescales. Millions of years, billions of years, stars growing old, and new ones forming, while galaxies slowly evolve. Yet these processes have been unfolding quietly since long before our planet existed, and they will continue long after our own sun has changed into a very different kind of star. If you could travel far into the future of our solar system, you would see our sun eventually entering the same stage, its outer layers swelling outward, its color warming into deeper orange and red, the familiar yellow sun of today transforming into a giant glowing sphere. But that future lies roughly 5 billion years ahead, a span of time so vast that the Earth itself will likely be very different by then. For tonight, it is enough simply to know that the stars we see above us are not static lights. They are living processes unfolding slowly across deep time. Some are young, some are in their long middle years, and some are ancient suns, glowing softly in the red giant phase of their lives, their atmospheres drifting outward into space, their interiors forging new elements, their light traveling patiently across the darkness. And as we continue this quiet journey through the lives of these stars, you don't need to follow every detail. You can simply listen as the story unfolds, like watching distant lights across a calm night sky, because somewhere out there, in the vast quiet of the galaxy, red giant stars are continuing their slow transformation, expanding gently, breathing in long cosmic rhythms, and releasing the atoms that will one day become part of entirely new worlds. Inside the vast outer atmosphere of a red giant star, motion never truly stops. From far away, the star may look calm, just a glowing orange sphere hanging quietly in the darkness. But within those enormous layers of gas, slow movements are always unfolding. One of the most important of these motions is convection. Convection is the same process that occurs in a pot of gently heated water on a stove. When the bottom of the pot warms, the heated water rises toward the surface. As it cools, it sinks again, creating slow, circulating currents. Inside stars, something similar happens. Hot gas rises from deeper layers where temperatures are higher. As that gas reaches the cooler outer atmosphere, it begins to lose heat and slowly sinks back downward. On the sun, these convection cells are already quite large compared with anything we see on Earth. But on red giants, the scale becomes almost unimaginable because the star has expanded so greatly. Individual convection cells can grow to extraordinary sizes. In some red giants, a single convective region may span a large fraction of the star's visible surface. If you could somehow observe the surface of such a star up close, you might see immense patches where hot gas slowly rises and glows more brightly. Nearby regions would appear slightly dimmer as cooler gas drifts downward again. These motions are slow, far slower than storms in planetary atmospheres. The movement may take months or even years to complete a single cycle. Yet, over long periods of time, these vast currents reshape the outer atmosphere of the star. They also help carry elements from deeper layers toward the surface. This quiet mixing process is important because the interior of a red giant is producing new elements that were not present when the star first formed. As helium fuses inside the core, carbon begins to appear, and in some stars, further reactions produce oxygen as well. Over time, convection slowly transports some of these newly formed atoms outward into the star's extended atmosphere. Eventually, many of them will leave the star entirely, because the outer layers of a red giant are only loosely held by gravity. The star's enormous size spreads its mass across a huge volume of space. As a result, the gravitational pull near the surface becomes much weaker than in younger stars. Gas in the outer atmosphere can drift outward relatively easily, and over long periods of time, red giants begin to lose mass, not through explosive eruptions, but through steady stellar winds. These winds are streams of gas slowly flowing away from the star. They move outward at speeds that can reach hundreds or even thousands of kilometers per second. But because space itself is so vast, the material leaving the star spreads out gradually, forming expanding shells of gas around the aging sun. Some of this material carries dust particles that formed in the cooling outer atmosphere. These grains are incredibly small, often no larger than tiny specks of smoke. Yet, they play an important role in the larger story of the universe, because dust is one of the key ingredients in the formation of planets. When stars like our sun eventually shed their outer layers, the material released into space contains a mixture of gases and dust enriched with elements created inside the star: carbon atoms, oxygen atoms, and many others. Over time, these atoms drift outward through the interstellar medium, the vast, thin mixture of gas and dust that fills the space between stars. At first glance, interstellar space might seem almost completely empty, but in reality, it contains enormous clouds of material spread across incredible distances. Some of these clouds are faint and diffuse. Others grow dense enough for gravity to slowly begin gathering their contents together. When that happens, something remarkable may occur. A new star can begin to form. Gravity draws the gas inward. The cloud collapses. Temperatures rise. And eventually, nuclear fusion begins again in the center of the collapsing mass. A new star ignites, and the cycle of stellar life begins once more. In this way, red giant stars quietly contribute to the ongoing renewal of the galaxy. The atoms they release become part of future generations of stars. Some of those stars will eventually develop planetary systems, and on rare occasions, those planets may contain the conditions needed for life. This means that many of the atoms that make up our own planet were once part of earlier stars. Carbon in living cells, oxygen in the air we breathe, iron in the rocks beneath our feet. Many of these elements were forged inside ancient stars that expanded into red giants long before the sun itself was born. Those stars lived their lives, expanded, released their outer layers, and the atoms they produced drifted quietly through space until gravity gathered them once again, eventually forming new stars, new planets, and new possibilities. From inside the system, it can be difficult to see the full shape of that story. Our lives unfold on timescales of decades. Human history stretches across thousands of years. Even the age of civilizations rarely exceeds a few millennia. But the processes shaping the galaxy unfold across millions and billions of years. Stars live long lives. Their transformations are slow and patient, and the red giant stage is one of the most important chapters in that long journey. It is a time when a star grows vast, when new elements are created deep within its interior, and when the star begins sharing its material with the surrounding universe. The light from such a star travels across space for years, centuries, or even millennia before reaching distant worlds. By the time that light arrives, the star itself may already have changed again. Yet the story of its life continues to unfold. And somewhere in the galaxy tonight, many stars are entering this gentle phase of expansion. Their atmospheres stretching outward into space, their surfaces glowing in warm shades of red, their interiors quietly forging new elements. If you were able to watch them over millions of years, you would see them slowly pulsing, expanding, contracting, releasing streams of gas that drift outward like faint cosmic breezes. But from our vantage point on Earth, we simply see a warm star, shining steadily in the night sky, a calm point of light, a distant sun nearing the later chapters of its long life. And if your thoughts wander as we move through these quiet cosmic processes, that's completely all right. The universe itself unfolds slowly. There's no need to follow every detail. You can simply rest here for a while, listening to the long story of the stars, because far beyond our world, the galaxy is filled with ancient suns slowly expanding into red giants, their atmospheres drifting gently outward, their light continuing its patient journey across the darkness of space, and their atoms beginning new journeys that will shape the future of the cosmos. As the long life of a red giant continues, its outer atmosphere becomes more than just an expanded layer of gas. It becomes a place where material slowly escapes the star's gentle grasp and begins a new journey into the wider galaxy. The process is gradual, almost patient. Unlike the dramatic explosions that sometimes mark the end of very massive stars, most red giants lose their outer layers through steady outflows. Astronomers call these outflows stellar winds, but the word wind can be a little misleading. These are not gusts or storms like those in a planetary atmosphere. Instead, they are slow streams of gas drifting outward, pushed away by radiation from the star and by the motion of material within its atmosphere. Over time, those winds carry enormous quantities of gas into surrounding space. A red giant can lose a significant portion of its mass this way, releasing it into the vast regions between the stars. And as this gas travels outward, it often cools enough for something new to appear within it. Tiny grains of dust. These dust particles are formed when atoms in the cooling gas begin sticking together. Carbon atoms may combine to form delicate soot-like grains. In other stars, silicon and oxygen form tiny crystals that resemble microscopic sand. Each grain is incredibly small, yet, collectively, they create faint clouds that drift away from the star. If you could observe one of these expanding clouds from far away, you might see a faint halo surrounding the aging star, a slowly widening shell of gas and dust spreading into the surrounding darkness. In many cases, this shell becomes visible as a planetary nebula, despite the name. Planetary nebulae have nothing to do with planets. Early astronomers gave them that name because through small telescopes they appeared as small round disks, somewhat like distant planets. In reality, they are the glowing remains of a star's outer atmosphere, as the red giant sheds its outer layers. The exposed core of the star becomes extremely hot. The intense radiation from this hot core illuminates the surrounding gas, causing it to glow. The result can be astonishingly beautiful. Rings of gas, delicate bubbles, expanding clouds shaped by invisible flows of stellar wind. Many planetary nebulae display intricate structures, glowing shells within shells, arcs of luminous gas, and delicate filaments stretching outward into space. But even these beautiful structures are temporary. Over tens of thousands of years, which in cosmic terms is a brief moment, the nebula continues expanding. The gas spreads thinner and thinner. Eventually, it fades into the surrounding interstellar medium. The visible glow disappears, and the material released by the star becomes part of the larger galaxy once again. Yet, at the center of the fading nebula, something remarkable remains. The core of the original star, now stripped of its enormous atmosphere. The core appears as a small, incredibly dense object called a white dwarf. White dwarfs are the quiet remnants of stars like our sun. They are about the size of Earth, but contain roughly the same mass the star once had. This means their density is extraordinary. Matter inside a white dwarf is compressed to such an extent that the familiar structure of atoms begins to change. Electrons are forced into extremely close proximity, creating a form of matter that behaves very differently from the materials we encounter on Earth. Yet despite this incredible density, the white dwarf itself is no longer producing energy through fusion. Its nuclear reactions have ended. Instead, the white dwarf simply radiates the heat it accumulated during its earlier life, slowly, patiently, over billions of years. At first, the white dwarf shines brightly with a bluish-white light, but as time passes, it gradually cools. Its glow fades. Given enough time, trillions of years, it will eventually become a dark, cold object, sometimes called a black dwarf. But the universe itself is not yet old enough for any black dwarfs to exist. Every white dwarf we observe today is still slowly cooling, still quietly radiating the remaining warmth of a star that once shone brightly for billions of years. In this way, the life of a star does not end suddenly. It fades gradually. A red giant becomes a planetary nebula. The nebula disperses into space, and the small, dense core remains as a white dwarf, glowing softly as it slowly releases the last of its heat. Meanwhile, the gas and dust expelled by the star continue their own long journey through the galaxy. These drifting materials become part of the interstellar medium, the vast mixture of gas and dust that fills the space between stars. In many places, the gas remains extremely thin, but in others, gravity begins to gather it together. Clouds form. These clouds may stretch across light years of space, containing enough material to create thousands of new stars. Within the densest regions of these clouds, gravity slowly pulls gas inward. The cloud contracts, temperatures rise, and eventually, nuclear fusion ignites once more. A new star is born. In this way, the atoms released by red giants help shape future generations of stars and planets. It is a quiet cycle that unfolds across billions of years. Stars form from clouds of gas. They shine for long ages. They expand into red giants. They release their material, and from that material, new stars eventually emerge. The galaxy is constantly renewing itself. Each generation of stars adds new elements to the cosmic mixture. Early stars in the universe contained mostly hydrogen and helium, but as generations passed, heavier elements accumulated: carbon, oxygen, iron, silicon, elements that would one day become part of rocky planets, oceans, and living systems. The story of red giant stars is therefore not only about stellar aging, it is also about the slow enrichment of the universe, a process that quietly builds the chemical complexity needed for planets and life. And the most remarkable part of that story is how ordinary it is. Stars like our sun are not rare. There are hundreds of billions of stars in the Milky Way galaxy alone, and many of them will eventually pass through the red giant stage. Right now, across the galaxy, countless stars are expanding into enormous glowing spheres, their atmospheres drifting outward, their interiors forging new elements, their light traveling outward through space. Some of that light has already been traveling for thousands of years before reaching us. When we look up at the night sky, we are not just seeing distant points of light. We are seeing moments in the long lives of stars, some young, some mature, some ancient and expanded, all part of the same slow cosmic cycle. And if your thoughts begin to drift as we continue through this quiet journey, that's perfectly natural. The universe itself moves slowly. Its stories unfold across ages far longer than our own lives. There is no need to keep track of every detail. You can simply rest with the idea that somewhere out there, in the deep quiet of the galaxy, red giant stars are continuing their gentle transformation, expanding softly, releasing clouds of gas and dust, and quietly preparing the raw materials from which entirely new stars will someday be born. Far beyond the glowing shells of planetary nebulae, the material released by red giant stars continues its slow passage through the galaxy. At first, those atoms move outward in expanding clouds. The motion is gentle, almost unhurried. Gas that once formed the outer atmosphere of a star now drifts through the vast spaces between other stars. Astronomers call this region the interstellar medium. It may sound like an empty place, but in truth, it contains a thin mixture of gas, dust, and faint radiation stretching across enormous distances. If you could travel through it, you would not see thick clouds the way we imagine clouds on Earth. Most regions are so diffuse that a spacecraft might move for kilometers before encountering even a few scattered atoms. Yet over the immense scale of galaxies, those atoms add up. Across the Milky Way, the interstellar medium contains enormous reservoirs of material: hydrogen, helium, carbon, oxygen, and countless other elements released by generations of stars. And among those elements are the atoms that once formed part of red giant stars. Some of them may drift for millions of years before encountering anything at all. Others slowly gather into larger clouds under the subtle influence of gravity. These clouds can grow vast. Some stretch across dozens or even hundreds of light years. Inside them, gas slowly collects into denser pockets. The process is delicate. Nothing happens quickly, but when enough material gathers together, gravity begins drawing it inward. The cloud slowly contracts. As it does, the gas becomes warmer. The atoms move faster, and gradually, the center of the cloud becomes denser and hotter. At a certain point, the conditions become extreme enough for nuclear fusion to begin once again. A new star ignites, and with that moment, the long cycle of stellar life continues. What is remarkable is that the new star may contain atoms forged inside stars that lived billions of years earlier. Carbon created in one red giant, oxygen produced in another, dust grains that once drifted away from ancient stellar atmospheres, all gathered together again by gravity to form a new sun. From inside the system, it can be difficult to see how interconnected these processes really are. Human life unfolds over decades. Civilizations last thousands of years, but the life cycles of stars stretch across millions and billions of years. The galaxy itself slowly changes over these immense spans of time. Early in the history of the universe, stars contained almost nothing but hydrogen and helium. Those were the simplest elements formed shortly after the Big Bang. But as generations of stars lived and died, heavier elements gradually accumulated. Red giants played an important role in that transformation. Inside their cores, helium fused into carbon. In some cases, further reactions produced oxygen and other elements. When those stars shed their outer layers, the newly created atoms spread through the galaxy, and when later generations of stars formed, they inherited those materials. Astronomers sometimes refer to this gradual change as the chemical evolution of galaxies. Over billions of years, galaxies slowly become richer in complex elements, and that enrichment changes what kinds of worlds can exist within them. Rocky planets like Earth require elements such as silicon, iron, and oxygen. Organic molecules require carbon. Water requires hydrogen and oxygen. All of these atoms were produced inside stars long before our solar system existed, which means that the story of red giant stars is not only a story about distant suns, it is also part of the deeper history of the matter that surrounds us. Some of the atoms in your own body may have once been inside the interior of a star, forged under tremendous heat and pressure, carried outward on stellar winds, drifting through interstellar space for ages before becoming part of a new planetary system, eventually becoming part of the Earth itself, and much later, part of living organisms. The connection between stars and life can feel abstract at first, but when astronomers trace the origins of elements through cosmic history, the link becomes surprisingly direct. The carbon in living cells, the oxygen in the air, the calcium in bones, many of these atoms were formed in stars that lived long before the sun was born. It's easy to miss how strange that really is. When we look up at the night sky, we see distant lights scattered across the darkness. But those lights represent ongoing processes that shape the very material of the universe. Stars are not just sources of light. They are places where matter itself is transformed. Hydrogen becoming helium, helium becoming carbon, and over countless generations, the universe slowly assembling the ingredients needed for planets and life. Red giants are one of the key chapters in that long story. They are the stage when many stars begin releasing the elements they have created. Their vast atmospheres expand, their stellar winds carry atoms outward, and their material becomes part of the interstellar medium. Over time, those atoms may travel incredible distances. Some will wander for millions of years before becoming part of another star. Others may eventually settle into disks of gas and dust surrounding newly forming stars. Within those disks, planets begin to grow. Tiny grains of dust collide and stick together. Small particles become larger ones, gradually forming rocks, planetesimals, and eventually entire worlds. In this way, the material released by ancient stars becomes the foundation of future solar systems. The universe slowly builds complexity through cycles that repeat across cosmic time. Stars form. They shine. They expand. They release their atoms. And those atoms eventually gather again to begin the cycle once more. From the perspective of human life, these processes unfold far too slowly to witness directly. Yet the evidence is written in the light of stars and in the composition of planets. Astronomers can measure the elements inside distant stars by studying their light. They can see how galaxies become richer in heavy elements over time. They can observe the glowing shells of planetary nebulae expanding into space. Each observation is a small window into a process that unfolds across billions of years, and quietly, patiently, the universe continues its work. Stars grow old. New ones ignite. Atoms drift across unimaginable distances, all part of a cycle that has been unfolding for nearly the entire age of the cosmos. If you imagine the night sky above you now, some of the stars shining there may already be red giants, ancient suns glowing softly in the later stages of their lives, their outer layers slowly expanding, their interiors quietly forging new elements, their light traveling across space toward distant observers. And perhaps the most remarkable part is that these transformations are not rare events. They are simply what stars do when given enough time. Most stars in the universe will eventually become red giants, including our own sun. But that future lies so far ahead that it almost feels like another era of the universe. For now, our sun is still in the long, stable middle of its life, shining steadily, balancing gravity and fusion. Yet even it will eventually change, just like the countless stars that have gone through this stage before it. And if your thoughts drift as we move through these immense spans of cosmic time, that's perfectly all right. The universe itself unfolds slowly. You can simply rest with the idea that the stars above us are not fixed lights. They are long-lived stories written in matter and energy, stories that continue unfolding across the galaxy. Even now, ancient red giant suns glowing softly in the darkness, their atmospheres drifting outward into space, their atoms beginning new journeys that will shape the next generation of stars. Somewhere in the wide spiral arms of the Milky Way, many stars are already living through the red giant stage right now. To our eyes, they appear as small points of reddish light scattered among thousands of other stars. Yet those tiny points represent objects of extraordinary size. Some red giants are so large that if they were placed in the center of our solar system, their outer atmospheres would extend far beyond the orbit of Mercury. Others would stretch past Venus. A few would reach nearly to the orbit of Earth. Yet, despite that enormous size, the outer layers of these stars remain remarkably thin. The gas in a red giant's atmosphere is spread across such vast distances that its density can become extremely low. In some places, the gas is thinner than the air in the highest reaches of Earth's atmosphere. It's a strange image to picture. A star hundreds of times larger than the sun, yet made of material so diffuse that it behaves almost like a glowing mist. From inside that atmosphere, the sky might look dim and copper-colored. The light from deeper layers of the star would glow through drifting clouds of hot gas. The horizon might appear soft and blurred, because there would be no solid surface to mark where the star truly ends. Instead, the atmosphere would gradually fade into the surrounding darkness of space, and within that enormous envelope of gas, motion would still continue. Slow convection currents, rising plumes of hotter material, sinking streams of cooler gas, the entire star gently circulating its outer layers over months and years. Astronomers sometimes observe subtle changes in the brightness of these stars as those currents move across the surface. A red giant might grow slightly brighter for a time, then dim again as different regions rotate into view. The star appears to pulse or shimmer faintly in the sky. Some red giants follow regular cycles of brightening and dimming. These are known as variable stars. One of the most famous examples is the star Mira, whose name means wonderful in Latin. Mira slowly brightens and fades over a period of about 11 months. At its brightest, it can be seen easily with the naked eye. At its dimmest, it becomes almost invisible without a telescope. The star itself is not exploding or erupting during these cycles. Instead, its enormous outer layers expand slightly and then contract again. The changes in size affect the temperature and brightness of the star's surface. It is almost as though the star is breathing, a slow, cosmic rhythm repeating over and over again. Many red giants show similar pulsations. Some follow very regular patterns. Others change more unpredictably, but the underlying cause is the same: the delicate balance between gravity, pulling inward, and energy pushing outward through the star's vast atmosphere. Even small shifts in that balance can cause the outer layers to move. The result is a gentle swelling and shrinking that takes place on a scale far larger than anything we experience on Earth. And during these cycles, the star continues to lose material. The pulsations help push gas outward. Dust grains form in the cooling layers of the atmosphere. Stellar winds carry that material away into space. Over time, the red giant gradually sheds more and more of its outer envelope. The process may continue for hundreds of thousands of years. Eventually, so much material has drifted away that the star's inner core begins to emerge. The outer atmosphere becomes thinner. The exposed core grows hotter. Radiation from that core begins illuminating the expanding shell of gas surrounding the star. This is the moment when a planetary nebula becomes visible. From Earth, some planetary nebulae appear as delicate rings of glowing gas. Others resemble luminous bubbles. Some show intricate structures shaped by magnetic fields or interacting stellar winds. The colors often appear soft and luminous: greens, blues, and reds created by different elements glowing under intense ultraviolet radiation. But even these beautiful structures are only temporary. The expanding gas continues drifting outward. over tens of thousands of years, it spreads thinner and thinner. Eventually, it fades into the surrounding interstellar medium. The nebula disappears, and only the small, dense core of the original star remains. That core, now a white dwarf, continues glowing quietly. Without nuclear fusion to sustain it, the white dwarf gradually cools. Its light slowly dims, yet it can continue shining for billions of years. During that time, the material once released by the red giant continues its journey through the galaxy. Dust grains drift between stars, atoms travel across enormous distances, and eventually, gravity gathers some of that material together again. The next generation of stars begins to form. This long cycle of stellar birth, life, and transformation has been repeating for almost the entire history of the universe. Each generation of stars leaves behind material that enriches the galaxy with new elements, and each generation of stars forms from the remains of those that came before. Our own solar system is part of that long chain. When the sun formed about 4.6 billion years ago, it was born from a cloud of gas and dust already enriched by earlier generations of stars. Within that cloud were atoms forged in ancient stellar interiors, carbon created inside red giants, iron produced in supernova explosions, silicon that would one day become part of rocky planets. Over time, gravity gathered that material into the young sun and the swirling disk of dust surrounding it. From that disk, the planets slowly formed. Earth emerged from countless collisions between small rocky bodies, and within the atoms that formed our planet were traces of stars that had lived and died long before. In a sense, the history of stars is written directly into the matter around us. Every rock, every ocean, every living cell, all contain atoms whose origins stretch back through generations of stellar life. When we look up at the night sky, we are seeing more than distant suns. We are seeing the ongoing processes that shaped the material of our own world. Some of those stars are young, some are in their long, stable middle years, and some are ancient red giants nearing the final stages of their stellar lives, their atmospheres slowly expanding into space, their interiors forging the elements that will shape the future, their light traveling patiently across the vast distances between stars. And if you imagine the sky tonight, filled with those distant points of light, it becomes easier to see the galaxy not as a static picture, but as a living system, a place where stars are constantly forming, changing, and passing on their material to the next generation, a place where red giant suns glow softly in deep orange light, where vast atmospheres drift outward into the darkness, where atoms wander through space for millions of years before finding a new home. And somewhere in that quiet cosmic cycle, the next generation of stars is already beginning to form. If your thoughts drift as we move through these long stellar stories, that's perfectly natural. The universe itself moves slowly. Its transformations unfold over spans of time far beyond the scale of human life. You can simply listen and let the story continue gently, like the slow turning of the night sky, because across the galaxy, red giant stars are still expanding, still glowing, still releasing their atoms into the vast ocean of space, and those atoms are already beginning the next chapter of their journey through the universe. Even while these enormous transformations unfold across the galaxy, most of the stars we see from Earth continue to appear steady and quiet. From our perspective, The sky seems almost timeless. The same constellations that guided ancient travelers across deserts and oceans still appear above us tonight. Orion still lifts its bright shoulder. Taurus still glows in the winter sky. The same red stars that were seen by observers thousands of years ago still shine with their soft color. Yet, within those distant suns, slow changes are always underway. Stars age so gradually that the transformation is almost impossible to notice during a human lifetime. But astronomy has given us a way to understand those changes by studying the light from stars. Astronomers can learn remarkable details about their temperature, size, composition, and age. The light from a star is not just brightness, it carries a pattern. When starlight is spread out into a spectrum, like a rainbow, it reveals thin, dark lines where specific wavelengths of light are absorbed by atoms inside the star's atmosphere. Each element produces its own unique pattern. Hydrogen leaves one set of lines, helium leaves another, carbon, oxygen, calcium, iron. Each leaves its own quiet fingerprint in the light. By carefully studying these patterns, astronomers can determine which elements are present inside a star and how abundant they are. This technique, called spectroscopy, allows scientists to read the chemical story written in the light of distant suns. And through spectroscopy, astronomers have learned that red giants often contain large amounts of elements produced inside their interiors. Carbon and oxygen appear in their atmospheres. Sometimes these elements are carried upward by the convection currents inside the star, gradually reaching the outer layers where their signatures appear in the starlight. In this way, the light from a red giant can reveal the quiet nuclear processes happening deep inside the star. But spectroscopy also reveals something else. It shows that different stars contain different mixtures of elements. Some stars are very rich in heavier elements. Others contain far fewer. These differences tell astronomers something important about the history of the galaxy. Stars that formed early in the universe contain mostly hydrogen and helium, because those were the only elements available at the time. Later generations of stars formed from gas clouds that had already been enriched by earlier stellar activity. Red giants, supernova explosions, and stellar winds gradually filled the galaxy with heavier elements. Each generation of stars inherited the materials left behind by those that came before. Astronomers sometimes describe this process using the idea of stellar populations. Population 1 stars, like our Sun, contain relatively high amounts of heavier elements. Population 2 stars, which are older, contain fewer heavy elements. And the very earliest stars, now long gone, were made almost entirely of hydrogen and helium. This slow enrichment of the galaxy has had enormous consequences. Without heavier elements, rocky planets could not form. Carbon chemistry would not exist. Life as we know it would not be possible. Yet the universe did not begin with these elements. They had to be created, and many of them were produced during the red giant phase of stellar evolution. In that sense, red giant stars are part of the universe's quiet workshop. Inside their cores, helium atoms combine to form carbon. Further reactions may create oxygen. In more massive stars, even heavier elements can appear. These atoms are then carried outward through stellar winds and eventually released into space. Over billions of years, This process slowly transforms the chemical composition of galaxies, and from that enriched material, new stars and planetary systems form. The cycle repeats, stars forming from clouds enriched by earlier stars, each generation adding new ingredients to the cosmic mixture. From inside our small corner of the universe, it is difficult to see the full scale of this process. Human history spans only a few thousand years. Even the entire age of our species is a tiny moment compared with the life of a single star. Yet, by observing thousands of stars across the sky, astronomers can piece together the broader story. They can see stars in different stages of life. Young stars forming in glowing nebulae, stable stars like our sun, shining steadily for billions of years, and older stars expanding into red giants. Each star represents a moment in a much longer cosmic cycle, and by studying them together, astronomers can reconstruct the sequence of stellar evolution. One of the most familiar red giant stars visible from Earth is Aldebaran. This star marks the bright eye of the constellation Taurus. Its warm orange light is easy to notice on clear nights. Aldebaran is not especially close to us by cosmic standards. It lies about 65 light-years away, but its brightness allows it to stand out among the stars nearby, like other red giants. Aldebaran has expanded far beyond the size it once had earlier in its life. Its surface temperature is cooler than that of the sun, giving it its distinctive orange glow. Yet its enormous size allows it to shine with many times the sun's total luminosity. The star is slowly evolving, just as countless other stars in the galaxy are doing. Its outer layers drift gently outward. Its interior continues its quiet nuclear reactions, and over immense spans of time, it too will eventually shed its outer layers and leave behind a white dwarf. Stars like Aldebaran remind us that stellar evolution is not an abstract idea. It is happening right now across the sky. Every red giant we see is a star in the later chapters of its life, a sun that has spent billions of years shining and is now slowly transforming. And when we look at those stars, we are seeing light that began its journey long ago. The light from Aldebaran reaching Earth tonight left the star about 65 years ago. Other red giants we observe may be hundreds or thousands of light years away. Their light began traveling toward us centuries or millennia before arriving here. This means that when we observe distant stars, we are always looking slightly into the past. Astronomy allows us to see moments in the lives of stars separated by enormous distances and times. Some stars we observe may already have changed further since the light we see left them, yet their light still carries the story of what they were like at that earlier moment. A moment when the star glowed softly as a red giant, expanding gently, releasing atoms into space, continuing the long cycle of stellar evolution that shapes the galaxy. And if you imagine the sky above you now, it becomes easier to see it not as a fixed pattern of lights, but as a living landscape, a place where stars are constantly forming and changing, where ancient red giants glow in deep shades of orange, where clouds of gas drift slowly between the stars, where new suns will one day ignite from material released by older ones. The galaxy is not still. It is always moving, always evolving. But it does so with a patience that stretches far beyond the scale of human life. Stars grow old slowly. Galaxies change gradually. Atoms travel quietly through space. And somewhere, Even now, new stars are beginning to form from the drifting remains of ancient red giants. You don't need to follow every detail of that story tonight. It is enough simply to know that the sky above us is full of these long, patient transformations. Ancient suns glowing softly, their atmospheres expanding into the darkness, their light continuing its journey across the vast quiet of the universe. And while the red giants we see in the night sky feel distant and ancient, they also help astronomers understand something closer to home, the future of our own sun. At the moment, the sun is still in the long, steady chapter of its life, known as the main sequence. Hydrogen continues to fuse quietly in its core, producing the light and warmth that reach Earth each day. This stage of stellar life is remarkably stable. For billions of years, the sun has maintained nearly the same size, brightness, and temperature. From the perspective of human history, it feels permanent, yet even the sun is slowly changing. The hydrogen in its core is gradually being converted into helium. That transformation has been happening since the sun first ignited about 4.6 billion years ago. And although the sun still has billions of years of fuel remaining, the balance inside it will eventually shift in the same way it has shifted for so many other stars. About 5 billion years from now, the hydrogen in the sun's core will become too depleted to sustain fusion there. When that happens, the core will begin to contract. The temperature in the contracting core will rise, and hydrogen fusion will begin in a shell surrounding the core, just as it does in other stars that enter the red giant stage. As that shell begins releasing more energy, the outer layers of the sun will start expanding, slowly at first. But over millions of years, the expansion will become dramatic. The sun's outer atmosphere will swell outward, growing many times larger than its current size. Mercury will likely be engulfed. Venus may also be swallowed by the expanding solar atmosphere. The future of Earth is more uncertain. Some models suggest that Earth may also be engulfed as the sun expands. Others suggest that changes in the sun's mass and gravitational influence could push Earth's orbit slightly outward. But even if Earth avoided being completely swallowed, the conditions on the planet would change long before that point. As the sun grows brighter and larger during the early stages of its red giant transformation, its energy output will increase. Temperatures on Earth would rise, oceans would gradually evaporate, the atmosphere would change. Over long spans of time, the surface of the planet would become increasingly hostile to life as we know it. Yet these changes would unfold extremely slowly. The first stages of increased solar brightness would occur hundreds of millions of years before the full red giant phase. In cosmic terms, the transformation would be gentle, measured not in years or centuries, but in geological ages. For now, however, that distant future remains unimaginably far away. The sun is only about halfway through its stable lifetime. It will continue shining steadily for billions of years to come. And during that time, the processes shaping the galaxy will continue unfolding quietly around us. Elsewhere in the Milky Way, stars slightly older than the sun are already expanding into red giants. Some have atmospheres stretching across distances larger than the orbit of Earth. Others have already shed their outer layers, leaving behind glowing planetary nebulae. Still others have completed their transformations entirely and now exist as white dwarfs, small, dense remnants slowly cooling in the darkness of space. By observing many different stars at many different distances, astronomers can piece together the full sequence of stellar life. Some stars show us the early stages, others reveal the middle chapters, and red giants offer a glimpse of what happens when stars begin to age. These observations allow scientists to construct models of stellar evolution, mathematical descriptions of how stars change over time. The models use the known laws of physics, gravity, nuclear reactions, thermodynamics, and the behavior of matter under extreme conditions. When these models are compared with real observations of stars across the galaxy, the results match remarkably well. Stars follow predictable patterns as they age. The size of a star, its temperature, its brightness, all change in ways that can be traced back to the physical processes unfolding in the stellar interior. This is one of the quiet triumphs of modern astronomy. Despite the enormous distances separating us from the stars, the light they send across space contains enough information for scientists to understand the forces shaping them. From tiny dark lines in a spectrum, from subtle variations in brightness, from careful measurements of distance and motion, astronomers can reconstruct the life stories of stars that exist hundreds or thousands of light years away. And through those observations, the red giant stage has become one of the most important chapters in the study of stellar evolution, because it reveals what happens when stars begin running low on their original fuel. It shows how new elements are created inside stars, and it explains how those elements eventually spread through the galaxy. When we look at a red giant star in the night sky, we are seeing a sun in the later stages of its life, a star that has already spent billions of years shining steadily, a star that has begun expanding, cooling, and transforming. Yet the transformation is not violent or chaotic. It is patient. The star grows larger, its light shifts toward warmer colors, its outer layers drift slowly outward into space, and deep within the star, new elements are quietly forming. Carbon, oxygen, atoms that will eventually become part of future stars, planets, and perhaps even living systems. The universe is filled with these quiet cycles: stars forming, stars aging, stars releasing their material back into the galaxy, and over billions of years, those cycles gradually reshape the chemistry of the cosmos. If you imagine the Milky Way as a vast spiral of light stretching across space, each star within it is part of that long story. Some stars are newborn, some are steady and mature, and some are red giants, ancient suns glowing softly as they approach the final chapters of their lives. Their atmospheres slowly drifting outward, their light traveling patiently through the darkness, and their atoms beginning new journeys that will help shape the next generation of stars. Even now, as we sit beneath the quiet sky, those distant processes are continuing. Stars expanding, nebulae glowing, new stars forming within cold clouds of gas, the galaxy itself slowly evolving across immense spans of time. And there is something deeply calming about that thought. The universe does not hurry. Its greatest transformations unfold slowly, across millions and billions of years. Stars grow old gently, galaxies change gradually, and somewhere far beyond our world tonight, ancient red giant suns are glowing softly in the darkness, their enormous atmospheres stretching outward into space, their light continuing its long journey through the quiet universe. And if your attention drifts as these long cosmic stories unfold, that's perfectly fine. You can simply rest here for a while, beneath a sky filled with stars that are quietly living out their own slow, patient lives. Across the wide disk of the Milky Way, these quiet stellar stories are happening all the time. In some distant corner of the galaxy, a red giant is expanding at this very moment. Its atmosphere is slowly swelling outward, its color deepening into warm shades of orange and red. Elsewhere, another star has already released its outer layers. A delicate planetary nebula glows faintly around the hot core left behind, and somewhere farther away, a newly forming star is gathering itself from a cloud of gas enriched by those earlier generations. The galaxy is never truly still, but its movement is patient, so patient that the changes often escape our notice. When we look up at the night sky, the stars appear almost perfectly stable. They rise, move across the sky, and set again in patterns that repeat night after night. Yet, beneath that calm appearance, every star is quietly evolving, and red giants are one of the most visible signs of that slow evolution. Their color alone hints at the story unfolding inside them. Most of the bright stars we see in the sky shine with white or bluish light, which means their surfaces are relatively hot. But red giants glow with a cooler, softer light. That warm orange color comes from the temperature of their expanded outer layers. Although their interiors remain incredibly hot, the enormous size of the star spreads the energy across a vast surface area. As a result, the surface temperature becomes lower than that of smaller stars. The star shines with a gentler hue, a soft amber glow in the darkness of space. If you compare the sun to a red giant, the difference becomes easier to imagine. The sun's surface temperature is about 5,500 degrees Celsius. Many red giants have surface temperatures closer to 3,000 or 4,000 degrees. Yet, because they are so much larger, their total brightness can still be hundreds or even thousands of times greater than the sun's. It is another quiet paradox of stellar physics. A cooler star can shine far more brightly if it becomes large enough, and as red giants expand, their enormous atmospheres radiate light across immense distances. That light travels through space for years, centuries, or even millennia before reaching distant observers. When we see a red giant star tonight, the light we are seeing may have begun its journey long before modern telescopes were invented. For stars thousands of light years away, the light reaching us tonight began traveling across the galaxy before many civilizations on Earth even existed. Astronomy allows us to look backward through time in this way. The greater the distance, the farther into the past we are seeing. Every star becomes a kind of message carried by light across the vastness of space, and among those messages are the quiet stories of red, giant stars. Some of them reveal stars just beginning their expansion. Others show stars already surrounded by faint clouds of gas drifting away from their surfaces. Some reveal stars whose outer layers have already been shed, leaving behind glowing planetary nebulae. By studying many of these objects together, Astronomers can trace the sequence of events that leads from one stage to the next. But perhaps the most fascinating part of this story is how common it is. The Milky Way contains hundreds of billions of stars, and many of those stars are roughly similar in mass to the Sun. Given enough time, most of them will eventually pass through the red giant phase. That means the galaxy is filled with aging suns. Stars slowly swelling to enormous sizes. Stars shedding their outer layers. Stars quietly enriching the interstellar medium with newly formed elements. From a distance, those processes may appear subtle, yet over billions of years, they reshape the chemistry of entire galaxies. Without red giants, many of the elements we take for granted would be far rarer. Carbon, for example, is one of the most important elements for life as we know it. Its ability to form complex molecules allows it to serve as the backbone of organic chemistry. Yet carbon was not created during the earliest moments of the universe. It had to be forged later inside stars. Red giants are among the places where that transformation occurs. Deep in their cores, helium nuclei collide and combine. 3 helium atoms fuse together to form a single carbon atom. It is a delicate reaction, requiring extraordinary heat and pressure. But once it begins, the star quietly produces carbon in large quantities. Over time, some of those atoms make their way into the star's outer layers, and eventually, they are released into space. Those atoms may wander through the galaxy for millions of years before becoming part of something new, a cloud of gas, a forming planet, perhaps even a living organism on some distant world. The idea that the atoms of life were once created inside stars has become one of the most profound insights of modern astronomy. It reminds us that the universe is not just a collection of distant objects. It is a connected system. Matter moves from star to star, from cloud to planet, from planet to living systems. The atoms that make up our bodies have long histories. Some were forged in ancient stellar interiors. Some traveled through interstellar space for ages before becoming part of Earth. And the cycle will continue long after our own sun has changed. Billions of years from now, when the sun itself expands into a red giant, it will begin releasing material into the galaxy as well. Those atoms will drift outward, joining the interstellar medium. Perhaps millions of years later, they will become part of a new star forming somewhere else in the Milky Way. The cycle of stellar life will go on. From our vantage point in the present, we can only glimpse small pieces of that immense story. Yet even those glimpses reveal something extraordinary. The night sky is not a static picture. It is a living record of cosmic change. Stars forming, stars aging, stars passing their material onward to future generations. And somewhere out there tonight, red giant stars are continuing their slow expansion, their atmospheres drifting outward, their light glowing softly across the darkness, their atoms beginning journeys that may last millions of years. You don't need to keep track of all those details. The universe itself is in no hurry. Its processes unfold gently across vast spans of time and beneath the quiet sky. Those distant stars continue their patient transformations, glowing softly as they grow old. And as we continue drifting through these quiet stories of aging stars, it can be helpful to pause for a moment and imagine what the galaxy itself might look like from far away, not from Earth, but from some distant vantage point far above the Milky Way's spiral arms. From that perspective, our galaxy would appear as a wide, slowly turning disk of light. Hundreds of billions of stars arranged in sweeping spirals, clouds of gas and dust scattered between them, regions where new stars are forming, and other regions where older stars are entering the final chapters of their lives. Among those older stars, red giants would be scattered like warm embers across the spiral arms, some glowing orange, some deeper red, each one marking a sun that has already spent billions of years shining, each one quietly expanding as its internal structure evolves. Yet the red giant phase is only one part of a star's long life story. Before reaching that stage, a star may spend most of its existence in a far calmer state. For a star like our Sun, that calm middle chapter lasts about 10 billion years. During that time, hydrogen fusion in the core continues steadily. The star maintains a nearly constant size and brightness. From the outside, it appears stable. But even during that long middle age, slow changes are happening. As hydrogen is fused into helium inside the core, the chemical composition of the star gradually shifts. The helium produced by fusion accumulates at the center. Over immense stretches of time, the helium core grows larger and denser. Meanwhile, the surrounding layers of hydrogen continue to burn, and slowly, almost imperceptibly, the balance of forces inside the star begins to evolve. The sun itself has already brightened slightly since it first formed, when the solar system was young. The sun produced less energy than it does today. Over billions of years, its luminosity has gradually increased as changes inside the core altered the way fusion proceeds. These changes are subtle on human timescales, but over geological ages, they become noticeable. Hundreds of millions of years from now, the sun will shine a little brighter still. Eventually, far in the future, those gradual changes will lead toward the same transformation that countless other stars have already experienced. The beginning of the red giant phase, but long before that distant future arrives, the Milky Way will continue its quiet evolution. Stars will keep forming inside cold molecular clouds. Massive stars will live short, brilliant lives before exploding as supernovae. Smaller stars like the sun will age more slowly, eventually expanding into red giants, and the galaxy itself will continue drifting through space. Orbiting the center of the Milky Way is another long journey entirely. Our sun, along with the entire solar system, travels around the center of the galaxy once every 230 million years or so. Astronomers sometimes call this a galactic year. Since the sun formed about 4.6 billion years ago, it has completed roughly 20 orbits around the galaxy's center. During that time, stars around us have come and gone. Some have formed, others have expanded into red giants. Some have already ended their lives and faded into white dwarfs. Yet the galaxy itself continues its slow rotation. The spiral arms shift gradually. Stars migrate through the disk. Gas clouds gather and disperse. And through it all, the cycles of stellar birth and transformation continue repeating. If you imagine the Milky Way as a vast living system, red giant stars represent one of its quieter stages of renewal. They are not explosive events like supernovae. They are not the dramatic birthplaces of new stars. Instead, they are patient transitions, stars slowly releasing their accumulated material back into the surrounding galaxy. Over time, that material becomes part of new clouds of gas, and from those clouds, new stars will eventually form. In this way, The life cycle of stars is closely tied to the evolution of galaxies themselves. Without red giants shedding their outer layers, the interstellar medium would contain far fewer heavy elements. The chemistry of galaxies would remain simpler. Planets like Earth might never form, but because stars evolve and release their material, galaxies slowly become richer in the ingredients needed for complex worlds. The atoms forged inside one generation of stars become the raw material for the next. The cycle continues across cosmic time, and if you imagine the sky above you tonight, filled with distant stars, some of those lights may already represent suns nearing the end of their long lives, ancient red giants glowing softly across the galaxy, their atmospheres slowly expanding outward, their stellar winds carrying atoms away into the darkness, their light traveling patiently across space toward distant observers. Some of that light may have begun its journey long before the earliest human civilizations appeared. Yet tonight, it arrives quietly at Earth, joining the soft glow of thousands of other stars in the night sky. From our perspective, those stars appear still, but the galaxy itself is always moving. Stars orbiting the galactic center, gas drifting through the spiral arms, new stars forming from the material released by older ones. And among those countless stars, red giants continue their slow transformation, their outer layers drifting gently outward, their cores quietly reshaping themselves under immense pressure, their atoms beginning new journeys that will eventually help shape the next generation of stars and planets. You don't need to follow every detail of those distant processes. The universe itself moves at a patient pace. You can simply imagine the vast spiral of the Milky Way turning slowly through space. Billions of stars shining softly, some young, some steady, some ancient and expanded, and scattered among them. Warm red giant suns glowing quietly as they grow old. And when astronomers look across the Milky Way, they can see these different stages of stellar life unfolding all at once. In one region of the galaxy, new stars are still forming inside vast, cold clouds of gas. These places often appear as glowing nebulae, where gravity slowly gathers material into dense knots that will eventually ignite as new suns. Elsewhere, stars like our own sun are quietly shining in the long middle years of their lives, stable, balanced, and steady for billions of years. And scattered throughout the galaxy are older stars that have already moved beyond that stable stage. Some of them are red giants, their surfaces cooler and redder than younger stars. Their atmospheres expanded across distances so large that entire planetary systems could fit inside them. From Earth, these stars appear small and quiet, but in reality, they are enormous. Take a moment to imagine standing on a planet orbiting a red giant star. The sky would look very different from the one we see on Earth. The star would appear enormous in the sky, filling a large portion of the horizon with a warm orange glow. Its light might feel softer than the sun's light today because the star's surface temperature is lower, but the sheer size of the star would still make it intensely bright. The daylight on such a world might carry a copper-colored hue. Shadows might appear softer and less sharp, and the star itself might slowly brighten and dim over time as convection currents and pulsations move through its vast atmosphere. But even on such a world, the deeper processes inside the star would remain hidden, far beneath the glowing outer layers. The core would continue its slow transformation, helium fusing into carbon, energy flowing outward through the surrounding shells, gravity pressing inward with relentless patience. These processes unfold over spans of time so long that even the lifetimes of planets may pass before a star completes its red giant phase. Eventually, however, the star's outer layers become too extended to remain bound forever. The stellar winds grow stronger, gas drifts away into space, and gradually the star loses more and more of its mass. The atmosphere that once stretched across immense distances begins to disperse. The exposed core grows hotter and brighter, and when enough of the outer envelope has been lost, the core's intense radiation begins illuminating the surrounding gas. The planetary nebula appears. From a distance, these nebulae can be among the most beautiful objects in the sky. Astronomers observing them through telescopes see delicate glowing rings, expanding bubbles, and faint filaments stretching across space. Some nebulae appear nearly circular. Others form complex symmetrical patterns shaped by magnetic fields and stellar winds. Their colors come from the different elements within the gas. Oxygen often glows with a soft greenish-blue light. Hydrogen may appear red. Other elements create faint violet or golden tones. Yet, despite their beauty, planetary nebulae are fleeting. They exist for only a brief period compared with the life of a star. As the gas continues expanding, it spreads thinner and thinner. Eventually, the glow fades. The nebula dissolves into the surrounding interstellar medium. What remains is the star's core, a white dwarf, small, dense, and slowly cooling. White dwarfs are among the most unusual objects in the universe. Although they contain roughly the mass of the original star, they are compressed into a sphere roughly the size of Earth. The density inside such an object is extraordinary. Matter behaves in ways that seem almost impossible by everyday standards. Yet, from a distance, a white dwarf appears simple, a small point of light, a quiet ember left behind after the long life of a star. Over billions of years, that ember slowly cools. Its brightness fades. Eventually, after unimaginable spans of time, it will become a dark, cold remnant drifting through space. But the material that once formed the star's outer layers will already have moved on. Atoms released during the red giant phase will be drifting through the galaxy. Some will become part of new clouds of gas. Others will be incorporated into forming stars. Some may one day become part of planets, and perhaps, on rare worlds, part of living systems. This long chain of transformation connects generations of stars across billions of years. Red giants play a key role in that chain. They are the stage where stars begin returning their material to the galaxy. The stage where elements created in stellar interiors are released into the wider cosmos. Without that process, the universe would remain much simpler. There would be far fewer heavy elements. Rocky planets would be rare. Complex chemistry would be difficult to achieve. But because stars evolve and release their atoms, galaxies slowly become richer in the materials needed for new worlds, and those cycles continue quietly across the Milky Way. Right now, somewhere in the galaxy, a star is entering its red giant phase. Elsewhere, another star is shedding its atmosphere into space, and somewhere else, a cloud of gas enriched by earlier stars is slowly collapsing into a new sun. The universe is full of these patient transformations, and when we look up at the night sky, we are seeing only a tiny glimpse of that vast, ongoing story. The stars appear calm, But their lives are long and eventful. They grow, they change, they release their atoms, and those atoms begin new journeys through the galaxy. If you imagine the night sky now, filled with distant stars, it becomes easier to see the galaxy, not as a still picture, but as a living system, a place where stars are constantly forming and transforming, where ancient red giant suns glow softly in deep shades of orange, where clouds of gas drift quietly between the spiral arms, where the atoms that once belonged to one star will someday help form another. And through it all, the galaxy continues turning slowly through space, billions of stars shining, some young, some mature, and some already expanded into enormous red giants glowing gently in the darkness. And if we pause for a moment and return to the quiet sky above us, it becomes easier to imagine how many of these stellar stories are unfolding at once. Every clear night reveals thousands of stars to the human eye. With telescopes, that number quickly grows to millions, and beyond that lie billions more scattered across the Milky Way. Each one is following its own long path through stellar life. Some are still young, newly formed from cold clouds of hydrogen gas. Some are in the long middle years of stability, shining steadily the way our sun does today. And others are older, suns that have already begun their slow expansion into red giants. Because stars live for such immense spans of time, the galaxy always contains examples of many different stages at once. Astronomers sometimes describe the galaxy as a kind of layered storybook. Each star represents a page in the life cycle of stellar evolution. By studying enough stars, scientists can piece together the full sequence. Young stars surrounded by swirling disks of dust, mature stars quietly fusing hydrogen, aging stars expanding into red giants, and finally, the quiet remnants left behind once their outer layers have drifted away. Red giants occupy one of the most fascinating chapters in that sequence, not because they are rare, but because they are so common. Most stars similar to the sun will eventually enter this phase. They will swell outward, their surfaces will cool slightly, their colors will deepen toward orange and red, their atmospheres will stretch across enormous distances, and slowly, almost imperceptibly, they will begin releasing their outer layers into space. These transformations unfold over millions of years, so slowly that even the most patient observers would never see the full process during a single lifetime. Yet astronomy allows us to see different examples of stars at different moments in that long story. Some red giants are just beginning to expand. Others have already grown hundreds of times larger than the sun. Some are surrounded by drifting shells of gas that hint at the planetary nebula they will soon create. And others have already completed that stage, leaving behind a small white dwarf glowing faintly in the darkness. By studying all of these stars together, astronomers can reconstruct the full path of stellar evolution. It is a bit like watching the life cycle of a forest. If you walk through a forest, you will see young saplings, mature trees, and old trunks slowly returning their material to the soil. Each tree represents a different moment in the life cycle of the forest. In much the same way, the galaxy contains stars at every stage of their lives, and red giants are the tall, aging trees of that cosmic forest. Large, ancient, and quietly returning their material to the surrounding environment. Over time, the atoms released by these stars drift through the interstellar medium. Some travel for millions of years before encountering another cloud of gas. Others become part of dense molecular clouds where new stars begin forming. In those clouds, gravity slowly gathers material together again. A new star ignites. A new solar system may begin to form. And within the dust surrounding that new star, tiny particles collide and stick together. Dust becomes pebbles. Pebbles become rocks. Rocks become planetesimals. And eventually, entire planets may emerge from that swirling disk of material. The atoms inside those planets may once have been part of ancient stars. Carbon created deep inside a red giant. Oxygen produced in a stellar core. Silicon formed during earlier stellar reactions, all gathered together again through the quiet pull of gravity. This long cycle connects the life of stars with the formation of planets and the chemistry of living systems. It is a reminder that the universe is not static. Matter moves, transforms, and recombines across cosmic time. The stars above us are part of that ongoing process. And if you imagine the Milky Way stretching across the sky as a faint band of light, you are looking at a vast city of stars. Hundreds of billions of suns shining together, some young and blue, some steady and yellow like our sun, and scattered among them, red giant stars glowing softly with warm orange light. These ancient suns mark the later chapters of stellar life, their atmospheres drifting outward, their interiors quietly forging new elements, their light traveling patiently across the darkness of space. If you could watch the galaxy for billions of years, you would see these transformations unfolding slowly. Stars swelling into red giants, nebulae expanding and fading, new stars igniting from the material left behind. But from our place in the present, we glimpse only brief moments of that immense story. Even so, those glimpses reveal something quietly beautiful. The universe changes, but it does so gently. Stars age slowly. Galaxies evolve patiently. Atoms travel across unimaginable distances before becoming part of something new. And somewhere out there tonight, in one of the spiral arms of the Milky Way, a red giant star is glowing softly in the darkness, its atmosphere stretching outward into space, its stellar winds carrying atoms away on long journeys through the galaxy. And long after its light has crossed the vast distance to reach us, those atoms will continue their quiet travels, beginning new chapters in the endless story of the stars. If you imagine the galaxy continuing its slow turning through space, the red giants scattered among its spiral arms begin to feel less like rare curiosities and more like familiar landmarks. They are the older suns of the Milky Way, stars that have already spent billions of years quietly shining and are now entering the later chapters of their long existence. From far away, a red giant's light carries a warmth that astronomers have learned to recognize, even through telescopes. The color is distinctive. The glow is not the bright white of a young, hot star, nor the bluish brilliance of a massive stellar giant. Instead, it is softer, a deep orange or reddish light that hints at the cooler outer atmosphere of a star that has expanded far beyond its earlier size. The color alone tells a story, because color in stars is closely connected to temperature. Hotter stars tend to shine white or blue. Cooler stars glow yellow, orange, or red. When a star grows into a red giant, its surface spreads outward across an enormous area. The energy produced inside the star must now radiate from this much larger surface. As a result, the temperature of that outer layer becomes lower than before, yet the star can still shine with tremendous brightness. In fact, many red giants are hundreds or even thousands of times more luminous than the sun. Their immense size compensates for their cooler surface temperature. It's a little like comparing a small hot flame with a vast glowing ember. The ember may be cooler, but its sheer size allows it to radiate far more light overall. Across the galaxy, these immense glowing embers mark the aging stages of countless stars. And because the red giant phase lasts for a significant portion of a star's later life, astronomers observe many examples of them in the sky. Some of them are nearby, others lie thousands of light years away. Yet, even the most distant ones still send their light across space, light that began its journey long before it arrived here. Every beam of starlight is a traveler moving through the darkness. Photons leaving the surface of a red giant spread outward in every direction. Some move into the empty depths of interstellar space, some pass through clouds of gas and dust, and a few eventually reach distant planets, telescopes, and eyes. When those photons arrive at Earth, they carry information about the star that produced them. Astronomers can measure their color, their intensity, the patterns of absorption created by atoms in the star's atmosphere. From those subtle clues, scientists can determine a star's temperature, its size, and the elements present in its outer layers. In this way, the light from red giant stars becomes a kind of message, a quiet signal, traveling across space, telling us about the conditions inside a star that may lie hundreds or thousands of light years away. And because light takes time to travel, those signals always represent moments from the past. If a red giant is 1,000 light years away, the light we see tonight left the star 1,000 years ago. In that sense, astronomy is a study not only of distant places, but also of distant times. Each star reveals a snapshot of its life at the moment. Its light began the long journey toward us. Across the galaxy, those snapshots combine into a larger picture. Young stars glowing in nebulae, stable stars quietly burning hydrogen, red giants swelling into enormous luminous spheres, white dwarfs slowly cooling after shedding their outer layers. Together, these stars reveal the full cycle of stellar evolution. But even with all this knowledge, there remains something deeply peaceful about simply looking up at the night sky, because the stars themselves are in no hurry. Their transformations unfold across spans of time so vast that they stretch far beyond the scale of human experience. A red giant may remain in that stage for hundreds of millions of years. During that time, its atmosphere will continue expanding and drifting outward. Its core will continue fusing helium into heavier elements. Its stellar winds will carry atoms into the surrounding galaxy. Gradually, patiently, the star will lose more of its outer layers. Eventually, the planetary nebula will form. The glowing shell of gas will expand outward, and the small white dwarf core will remain. Yet even that final stage is not truly an ending, because the atoms released during the red giant phase will continue traveling through the galaxy. Some may wander for millions of years before encountering a new cloud of gas. Others may eventually be pulled into the formation of new stars. Some may become part of rocky planets forming around distant suns, and perhaps on rare worlds. Those atoms may take part in something even more remarkable: the chemistry of life. In this way, the life cycles of stars connect distant regions of space across immense spans of time. Material released by one star becomes the foundation for future generations. Red giants play an essential role in that quiet chain of transformation. They are the moment when a star begins returning its accumulated material to the galaxy, the moment when atoms created deep within a stellar interior are released back into the wider cosmos. From our perspective on Earth, those processes feel distant and abstract, yet they are part of the same universe that surrounds us. The atoms in our own bodies have histories that stretch back through those same cosmic cycles. Many of them were created inside stars that lived long before the sun formed. They traveled across space. They became part of the cloud that formed our solar system, and eventually, they became part of the Earth itself. So when we look up at the night sky, we are not just seeing distant objects. We are seeing pieces of a much larger story, a story in which stars grow, change, and pass on their material across generations. And among the countless lights of the galaxy, red giants glow softly as the elders of that stellar community. Ancient suns shining with warm light, their vast atmospheres slowly drifting outward, their atoms beginning journeys that will shape the future of the galaxy. And if your thoughts drift as you imagine those distant stars, that is perfectly all right. The universe itself unfolds slowly. Its stories stretch across billions of years. You can simply rest beneath the quiet sky, knowing that somewhere out there, red giant stars are still expanding gently in the darkness. And when we think about those distant stars continuing their quiet transformations, it can be comforting to remember just how slowly the universe moves. Human lives unfold across decades. Civilizations rise and fall across centuries. Even the longest chapters of human history span only a few thousand years. But the lives of stars stretch far beyond that scale. A star like our sun spends roughly 10 billion years in its stable middle age. Its red giant phase alone can last hundreds of millions of years. The white dwarf that remains afterward may continue glowing faintly for billions more. These spans of time are so vast that they almost feel like stillness. Yet within that stillness, the universe is always changing. Stars grow older. Galaxies slowly evolve. Atoms drift across unimaginable distances. And red giant stars play a quiet role in all of it. They are part of the long rhythm of cosmic recycling. Inside their cores, helium fuses into carbon and oxygen. In their outer layers, convection currents carry those elements upward, and through gentle stellar winds, those atoms are released into the galaxy. Once free, the atoms begin new journeys. Some travel through interstellar space for millions of years. Others gather inside vast clouds of gas, where gravity slowly begins forming new stars. Over time, new suns ignite, new solar systems appear, and within those systems, planets may slowly grow from the dust left behind by earlier stars. The cycle continues, from star to cloud, from cloud to star again, generation after generation. The galaxy renewing itself through the patient evolution of its stars. When we look at the Milky Way stretching across the night sky, we are seeing the light of billions of suns. Some of those stars are young, some are mature, and many are ancient red giants quietly approaching the later chapters of their lives. Their warm light travels across space, reaching distant worlds long after it left their surfaces, and somewhere in those distant systems, perhaps another observer might be looking up at their own night sky, seeing the same quiet glow of aging stars, wondering about the stories hidden inside those distant lights, because the life cycle of stars is one of the great patterns of the universe. It unfolds everywhere, across galaxies, across cosmic time, yet it does so gently, without urgency, without haste. Stars take billions of years to grow old. Their transformations are gradual, their light steady, and their final stages are not violent endings, but quiet transitions. Red giants expand, their atmospheres drift outward. Planetary nebulae glow briefly and fade. White dwarfs remain as small, dense embers slowly cooling in the darkness, and the atoms once locked inside those stars begin new journeys through the galaxy, eventually becoming part of new stars, new planets, perhaps even new forms of life. If we step back and look at the universe this way, the night sky begins to feel less like a distant display and more like a living system, a place where matter moves through endless cycles of change, where stars grow old with patience, where galaxies evolve slowly over billions of years, and where even the quiet glow of a red giant star carries the memory of ancient processes unfolding across deep time. Tonight, somewhere out there in the vast spiral arms of the Milky Way, countless red giant suns are glowing softly, their enormous atmospheres drifting outward into space, their interiors quietly shaping the elements that will one day become part of future stars and planets, their light traveling patiently through the darkness of the universe. And here beneath our own quiet sky, we can simply rest with that thought. The stars above us are not fixed lights. They are long, slow stories, stories unfolding across billions of years, stories that continue whether we watch them or not. And if sleep has already begun to find you, that's perfectly all right. The stars will keep shining, the galaxy will keep turning, and the quiet work of the universe will continue gently through the night. There is nothing more you need to do now. You can simply rest. Far beyond the quiet glow of the nearest stars, the galaxy continues its slow and patient work. Clouds of gas drift between the spiral arms. Some of those clouds are cold and dark, almost invisible except where they block the light of distant stars behind them. Inside these quiet regions, gravity is always at work, gently gathering atoms together. Over long stretches of time, small pockets of gas begin to grow denser. The atoms move closer. The cloud slowly contracts. Temperatures rise in the center, and eventually, a new star begins to take shape. When that moment arrives, nuclear fusion ignites once again in the heart of the forming star. Light begins pouring outward, and a new sun joins the countless others scattered across the Milky Way. But the material that forms that new star rarely comes from pristine gas alone. Much of it carries a long history. Atoms created inside earlier generations of stars are often mixed into these clouds. Carbon that once formed inside a red giant's core, oxygen released during a stellar wind, tiny grains of dust that drifted away from a fading planetary nebula. All of these ingredients become part of the next generation. In this way, The galaxy slowly accumulates complexity. Early in the universe, the first stars formed from gas made almost entirely of hydrogen and helium. Those early stars were the pioneers of stellar chemistry. Inside them, the first heavier elements were forged. When those stars ended their lives, they released their material into space. Later generations of stars formed from that enriched gas, and with each generation, the chemical mixture of the galaxy grew more varied. Red giants play an especially important role in that gradual enrichment. Inside their cores, helium fuses into carbon. In some stars, carbon combines with helium to form oxygen. These elements are among the most important ingredients for rocky planets and organic chemistry. When red giants release their outer layers, those atoms are carried outward into the galaxy. Over billions of years, that slow release of material changes the composition of the interstellar medium. Clouds that once contained only simple elements gradually become richer in complex ones. And from those clouds, new stars and planets eventually form. It's a quiet process, one that unfolds across immense spans of time. Yet, it is one of the reasons the universe today contains such a wide variety of worlds. Without generations of stars slowly enriching the galaxy with heavier elements, planets like Earth would be far less common. The atoms needed for rocks, oceans, and living systems would remain rare. But because stars live and evolve, galaxies slowly become fertile environments for new kinds of structures to appear. Stars form, stars age, stars return their material to space, and the next generation begins again. If you imagine the Milky Way from far above its spiral arms, you might see this cycle unfolding across the galaxy. New stars lighting up inside glowing nebulae, older stars expanding into red giants, faint planetary nebulae drifting outward, white dwarfs slowly cooling after their long lives of fusion. And scattered among all of this activity are countless clouds of gas, waiting quietly for gravity to begin the next round of star formation. The galaxy is like a vast ecosystem of stars. Each stage of stellar life plays a role in shaping the environment for the stages that follow. Red giants are one of the gentle turning points in that system. They mark the moment when stars begin returning their accumulated matter to the galaxy. The moment when atoms forged deep within stellar interiors begin their journeys outward. If we look up at the night sky now, some of the red stars we see may already be in that stage. Their atmospheres expanded, their surfaces glowing with warm orange light, their stellar winds carrying atoms away into the surrounding darkness. From Earth, they appear quiet and steady, yet inside those distant suns, slow processes continue unfolding. Helium fusing into heavier elements, convection currents stirring the outer layers, gas drifting away into space. These changes are subtle from our perspective, but over millions and billions of years, they reshape the galaxy itself. The atoms produced in those stars will not remain there forever. They will travel. They will mix with other clouds of gas, and eventually, they will become part of new stars, perhaps even part of new planetary systems. Some of those future worlds may orbit stars that have not yet formed. Their atoms are still drifting through the interstellar medium, waiting, gathering slowly into new clouds. It may seem almost impossible to imagine such long journeys, atoms traveling across space for millions of years before finding a new home. Yet this is the quiet rhythm of cosmic time. Nothing is rushed. Matter moves slowly. Stars evolve gradually, and the universe patiently recycles its ingredients again and again. If you imagine the galaxy turning slowly through space, the red giants become part of that gentle motion. Enormous stars glowing softly as they age, their light spreading outward across the darkness, their material drifting into the vast ocean between the stars, and eventually becoming part of something new. The next generation of suns, the next formation of planets, the next quiet chapter in the story of the cosmos. And if your attention drifts while these distant processes unfold, that's perfectly fine. The universe itself moves slowly enough that nothing needs to be hurried. You can simply rest beneath the night sky, while far away, red giant stars continue their patient transformation. As those distant stars continue their slow transformations, the night sky above us begins to feel a little different. At first glance, it still appears calm and unchanged. The constellations hold their familiar shapes. Orion rises in winter. The curve of the Big Dipper swings slowly around the northern sky. But once you know the stories hidden inside those distant lights, the sky becomes something more than a pattern of stars. It becomes a landscape of time. Every point of light represents a star at a particular moment in its life. Some of them are still young, burning brightly as they begin their long existence. Others are in the stable middle of their lives, quietly fusing hydrogen deep in their cores, and some are already in their later chapters, ancient stars that have expanded into red giants, their atmospheres stretched outward across enormous distances, their surfaces glowing with warm shades of orange and red. When we see those stars tonight, we are witnessing a stage of stellar life that has already unfolded across billions of years. The star has spent an immense span of time quietly shining before reaching this point. Only after that long middle age does the transformation into a red giant begin. Even then, the change happens gradually. The star does not suddenly expand. Instead, the internal balance shifts slowly as the hydrogen in the core becomes depleted. The core contracts, the temperature rises, fusion begins in a surrounding shell, and the outer layers of the star begin their long expansion into space. Over millions of years, the star grows larger and larger. Its color deepens. Its atmosphere becomes more diffuse. Eventually, the star may grow hundreds of times larger than it once was. And while all of this happens, the star continues shining. Light leaving its surface every second. Light that spreads outward through the darkness of space. Some of that light travels toward distant planets. Some wanders into empty regions between the stars. And a tiny fraction eventually reaches Earth. When those photons arrive here, they carry a message from far away. A message that began its journey long ago. In some cases, the light we see tonight left its star before modern science even existed. For stars, hundreds or thousands of light years away, their light may have begun traveling toward us before the first telescopes were built. Yet, even after all that time, the signal remains, a quiet beam of energy crossing the vast distances of the galaxy. And by studying that light, astronomers can learn remarkable things about the star that produced it. They can determine its temperature, its size, the elements present in its atmosphere, even the way its brightness changes over time. All of this information is hidden within the light itself, which means that when we observe red giant stars, we are not just seeing their glow. We are reading the physical conditions of objects that lie far beyond the reach of any spacecraft. It is a quiet kind of communication across space. The star radiates its light. The light travels outward, And eventually, somewhere in the galaxy, an observer receives that signal. From that signal, the story of the star can be reconstructed, and those stories reveal that red giants are not isolated events. They are a natural stage in the life of many stars. The galaxy is filled with them. Across the spiral arms of the Milky Way, countless stars are currently passing through this phase. Some are enormous supergiants, visible from thousands of light years away. Others are smaller red giants quietly expanding after billions of years of stable fusion. Together, they form a population of aging suns scattered throughout the galaxy, each one slowly releasing atoms into space, each one contributing to the chemical richness of the interstellar medium. And over immense spans of time, the galaxy itself changes because of this process. New elements accumulate. Clouds of gas become richer in complex atoms. New generations of stars inherit those materials. The cosmic cycle continues. From the perspective of our own lives, these processes feel almost motionless. The stars we see tonight will look nearly the same tomorrow. They will look the same next year, even thousands of years from now. The patterns of the constellations will still be recognizable, but over millions of years, the galaxy is always shifting. Stars move along their orbits. Nebulae expand and fade. New stars ignite inside dark clouds, and red giants quietly age, their enormous atmospheres drifting outward, their interiors forging elements that will shape the next generation of stars. If you imagine the Milky Way as a great spiral of light slowly turning through space, the red giants become part of that larger motion. Warm embers scattered through the galaxy, ancient suns glowing softly as they grow old, their light continuing to cross the darkness between stars, and their atoms beginning new journeys through the vast interstellar medium. You don't need to hold on to every detail of that story tonight. The universe itself moves at a patient pace. Its changes unfold slowly, across spans of time far longer than our own lives. It is enough simply to know that the sky above us is full of these quiet transformations, stars expanding, stars releasing their atoms, stars preparing the raw material for future worlds, and somewhere far away, beyond the reach of our own sun's light, red giant stars are glowing gently in the darkness, continuing their long, patient lives. And as those distant stars continue their quiet work, it becomes easier to feel the deep patience of the universe. Nothing in the life of a red giant happens quickly. Even the dramatic moments in a star's evolution unfold across timescales that feel almost timeless to us. Millions of years pass while a star expands. Millions more while its outer layers drift outward into space. The changes are real, but they are unhurried. And in that slow rhythm, the galaxy quietly reshapes itself. Somewhere in the Milky Way tonight, a star just slightly more massive than the sun may be entering the earliest stage of its red giant transformation. Deep in its interior, hydrogen fusion in the core has already slowed. The balance between gravity and pressure has begun to shift. The core contracts a little. The surrounding layers respond, and very gradually, the star begins to grow. No sudden flash marks the beginning of this stage. There is no clear boundary that separates the steady life of the star from the moment it begins to age. Instead, the transition unfolds gently. Over millions of years, the outer layers expand outward, becoming more diffuse and cooler. the color of the star shifts toward deeper shades of orange. The star brightens as its surface area increases. From far away, another quiet red giant joins the population of aging suns scattered across the spiral arms of the galaxy. Astronomers often find these stars clustered in certain regions of the sky, especially within old stellar groups known as globular clusters. These clusters are some of the oldest structures in the Milky Way. Each contains hundreds of thousands of stars, bound together by gravity, moving as a group through the halo of the galaxy. Because the stars inside a globular cluster formed around the same time, astronomers can study them as a kind of natural laboratory for stellar evolution. Many of the stars in these clusters have already reached the later stages of their lives. Among them are numerous red giants, shining with warm orange light. When astronomers map the brightness and color of stars in these clusters, they see a pattern known as the red giant branch. This pattern reveals the evolutionary path that aging stars follow as they expand and cool. It is one of the most elegant diagrams in astronomy, a quiet curve traced by stars as they move from their stable middle age toward the red giant phase. Each point along that curve represents a star at a slightly different moment in its long life. Together, they form a visible record of stellar aging. In this way, globular clusters offer a glimpse into the future of many stars. They show what happens when stars like the Sun grow older. They show the gentle expansion into red giants, the shedding of outer layers, the formation of white dwarf remnants. By studying these clusters, astronomers can test their models of stellar physics with remarkable precision. The predictions made by theory match closely with the patterns seen in real stars. Gravity, nuclear reactions, and the flow of energy through stellar interiors combine to produce the quiet evolution that red giants represent. And yet, even with all of that scientific understanding, there remains something deeply simple about the sight of a red star in the sky. Long before modern astronomy existed, observers noticed that certain stars glowed with a reddish hue. Ancient sky watchers saw them too. They named them. They placed them within constellations. They wondered about their meaning. One of the most famous examples is Betelgeuse, the bright red star marking the shoulder of Orion. Betelgeuse is a massive red supergiant rather than a typical red giant, but its deep color has fascinated observers for centuries. It is enormous, so large that if it were placed at the center of our solar system, its outer atmosphere might extend beyond the orbit of Mars. Yet even such an immense star follows the same fundamental principles of stellar evolution, its internal balance slowly changing, its atmosphere swelling outward, its light glowing softly across the darkness. When we look at stars like Betelgeuse or Aldebaran, we are seeing a stage of stellar life that has already unfolded across immense spans of time. The star has lived through billions of years before reaching this moment, and now it glows with the warm color of an aging sun. Some of these stars pulsate gently, their outer layers rising and falling like slow breaths. Others release steady streams of gas into space, forming faint clouds around them. All of them are part of the same quiet chapter in the life cycle of stars, the chapter where the star begins returning its material to the galaxy, and as that material drifts outward, it carries with it the atoms forged deep within the stellar interior: carbon, oxygen, elements that will one day become part of new stars and planets. The story continues long after the red giant phase ends. Planetary nebulae expand and fade, White dwarfs cool slowly in the darkness, and the atoms once contained within those stars begin new journeys through the Milky Way. Some of those atoms will wander through space for millions of years before encountering another cloud of gas. Others may be gathered into forming stars sooner, but eventually, the cycle continues. The galaxy renews itself through these slow transformations, and if you imagine the Milky Way turning gently through space tonight, you can picture countless red giant stars scattered across its spiral arms, ancient suns glowing softly, their atmospheres stretching outward, their light traveling patiently across the vast distances between the stars. From our small world beneath the night sky, those distant transformations are almost invisible, yet they are always happening. The universe is never truly still, but it moves with a calm that stretches far beyond the rhythms of human life. And somewhere out there tonight, far beyond the reach of our own sun's light, red giant stars continue their quiet expansion, glowing softly as they grow old. And as these ancient suns continue their slow transformations, the galaxy quietly carries on with its endless rhythm. Stars are born. Stars grow older. Stars release their atoms back into space, and new stars slowly emerge from the material left behind. It is a cycle so vast that no single observer could ever watch it from beginning to end. Yet the pieces of that story are scattered all across the sky. In one region of the Milky Way, a cloud of gas is slowly collapsing to form new stars. In another, a mature star shines steadily in the long middle of its life. And somewhere else, a red giant is gently expanding, its outer layers drifting outward into the darkness. All of these moments exist at once. They are different chapters of the same cosmic story unfolding across billions of years. Red giant stars are one of the quiet turning points in that story. They represent the moment when a star begins returning its material to the galaxy that once formed it. Inside the core of the star, helium continues to fuse into heavier elements. Energy flows outward through the surrounding layers, and the star's enormous atmosphere gradually becomes more diffuse, slowly loosening its grip on the gas that surrounds it. With time, those outer layers slip away, carried outward by stellar winds, spread gently across interstellar space. And although the loss of that material may seem like the end of something, it is also the beginning of something else, because those atoms will not remain alone forever. They will drift, they will mix with other clouds of gas and dust, and eventually, gravity will begin gathering them together again. New stars will ignite, new solar systems will appear, and the atoms that once glowed inside a red giant may become part of entirely new worlds. Perhaps rocky planets circling distant suns, perhaps icy bodies drifting through dark outer systems, or perhaps, on rare worlds, part of the chemistry that allows life to emerge. All of that begins with stars quietly aging and releasing their material into the galaxy, which is why red giants are so important in the long story of the cosmos. They are not violent endings. They are gentle transitions, moments when a star that has spent billions of years shining begins to give something back to the universe around it. And this process is happening everywhere, across the Milky Way's spiral arms, inside distant star clusters, even in neighboring galaxies far beyond our own. The same quiet transformations unfold again and again. Stars expanding, stars shedding their atmospheres, stars leaving behind faint white dwarfs that slowly cool in the darkness, and the atoms released along the way begin new journeys through space. It is a rhythm that has been repeating since the earliest generations of stars. The first stars formed from simple hydrogen and helium. Later stars formed from clouds enriched by those earlier ones. And over billions of years, the chemistry of the universe has gradually grown more complex. Planets formed, oceans appeared. Life began on at least one small world, orbiting an ordinary yellow star. All of it connected to the long cycle of stellar birth and transformation. And when we look up at the night sky tonight, we are seeing only a small part of that immense process. The stars appear steady, their patterns familiar, but behind that calm appearance lies a galaxy constantly evolving across deep time. Ancient stars expanding into red giants, nebulae, glowing faintly where stars have released their outer layers, new suns forming quietly inside dark clouds of gas. The universe is always moving forward, yet it does so with remarkable patience. Nothing is rushed. Stars grow old slowly. Galaxies change gradually. Atoms travel through space for millions of years before finding new homes. And somewhere in the spiral arms of the Milky Way tonight, a red giant star is glowing softly in the darkness, its atmosphere stretching outward into space, its light traveling patiently across the galaxy, its atoms beginning long journeys that may last far longer than our own civilization has existed. You don't need to hold on to every detail of that story. The universe itself unfolds slowly enough that nothing needs to be remembered perfectly. It is enough simply to imagine those ancient stars glowing quietly, warm red giants scattered across the vast spiral of the Milky Way, their light drifting gently through space, their long lives continuing in calm and patient silence. And here, beneath the quiet sky, you can simply rest, while those distant suns continue their slow and beautiful stories among the stars. And now, as our quiet journey among these ancient stars begins to slow, the galaxy continues its patient motion beyond us. Somewhere far away, a red giant star is still expanding, its outer layers drifting outward like a vast, glowing atmosphere, its light spreading gently across the darkness, traveling for years, centuries, sometimes thousands of years before reaching distant worlds. Deep inside that star, nuclear reactions continue quietly. Helium becomes carbon. Carbon may become oxygen. The slow chemistry of stellar life unfolding in silence. Around the star, faint streams of gas drift outward into the galaxy, carrying atoms that will one day become part of something new. A cloud of gas, a forming star, perhaps a planet circling a sun that has not yet been born. These transformations happen slowly, almost imperceptibly. Millions of years pass while a star grows larger. Millions more while its atmosphere drifts into space. Even the glowing shells of planetary nebulae expand for thousands of years before fading quietly into the interstellar medium. And through all of it, the galaxy continues turning. Our own sun moves steadily along its orbit around the Milky Way's center. The spiral arms shift gradually. Stars wander through the galactic disk. Clouds of gas gather and disperse. New stars ignite. Old stars expand into red giants. The cycle continues. When we look up at the night sky, it can be easy to imagine the stars as fixed points of light. But now you know that each of those lights is part of a long and gentle story, a story of birth, balance, change, and renewal. Some of the stars shining tonight are young, some are steady and mature, and some are ancient red giants, glowing softly in their later years. Their atmospheres stretched across vast distances, their interiors quietly forging the elements that will shape the future of the galaxy. The atoms released by those stars will travel far beyond their original homes. Some will drift through the Milky Way for millions of years. Others will become part of new clouds of gas. Eventually, gravity will gather those atoms together again. New stars will ignite. New planets will form. And somewhere, perhaps, new observers will look up at their own night sky. They may see distant red stars glowing with warm orange light. They may wonder about the lives of those stars, about where their atoms came from, about how long those distant suns have been shining. In that way, the story of the stars continues across generations, across civilizations, across immense spans of time. But tonight, here beneath our own quiet sky, there is no need to follow every thread of that cosmic story. The universe itself is patient. Its greatest changes unfold slowly. Stars grow old gently. Galaxies evolve calmly. And the ancient red giants scattered across the Milky Way will continue glowing long after this night has passed. If your attention has drifted along the way, that's perfectly fine. You were never meant to hold on to every detail. These stories were simply meant to accompany the quiet hours, to remind you that beyond the noise of the day, the universe moves with a deep and steady calm. Somewhere far away, red giant suns are still shining, their warm light traveling slowly across the darkness, their long lives unfolding across billions of years. And here, beneath the same vast sky, you can simply let your thoughts grow quiet, your breathing slow, your body at rest. The stars will continue their patient work above you. The galaxy will keep turning, and there is nothing more you need to do tonight. You can simply let yourself rest